There is a special situation where for an infinite series we can work out what the limit is, and those series are called telescoping series. The property they have is that as you take successive terms in the series, most of them cancel with another term in the series, because one will have a positive value and one will have a negative value, until you end up with very few terms which are finite or have a limit of 0, and we can work out what the limit is. Taking 1 over n times n plus 1, the first step is to separate the expression using partial fractions and then write out the terms by substituting values of n, 1, 2, 3, 4, 5. If you go up to some fixed value, large N, you'll see that most of the terms will cancel. The minus a half will cancel with the plus a half. The minus a third will cancel with plus a third, and so on, until you end up with 1 minus 1 over n plus 1. From earlier work, we know that 1 over n plus 1 is going to eventually become 0 as n tends to infinity. The sum of the original series will tend to the limit 1. If we look here and we add successive terms for n equals 1, the sum is a half. N equals 2, the sum is 1 minus a third, or 2/3. Add another term, the sum is 0.75. Let's add another 8 terms, and the sum is 0.9, which is getting closer to 1. Add another 8 terms, and you can see here that most of the terms have cancelled out, and the sum is 0.95, and that's getting closer to 1, and so on. The next example is the sum of the ln of n plus 1 over n. That is ln 2 plus ln of 3 over 2 plus ln of 4 over 3. Using the rules for the definition of a logarithm, for example, ln of 3 over 2 is ln of 3 minus ln of 2. Again, most of the terms will cancel. Let's add the first term, ln of 2. Next one, ln of 3. Next one, ln of 4. Next one, ln of 5. Ln of 6. This sum is diverging. Finally, the sum of the square root of n plus 1 minus the square root of n. Again, in this case, the sum will tend to infinity. And we can test that by adding more and more terms. We can see that we've got the square root of 13, 14, 15, 16, which is going to diverge.